32, we're going to talk about altitudes and medians of triangles. Hopefully I can, help you make some sense out of this. The median of a triangle is a segment of a triangle or in a triangle whose endpoints are the vertex. Every triangle has three vertexes or vertices, right? So it's one of the endpoints is going to be the vertex, and the other one is going to be the midpoint of the opposite side. And I've got visuals for all of this so you can see what we're talking about. But every triangle has one median for each vertex that's going to go back to the midpoint of the opposite side. So every triangle should have three medians, or will have three medians. Okay, the total or the point of concurrency is where those three lines are going to cross at. Those three medians cross, and it has a special name. We call that the centroid of a triangle. And that's a word or a phrase that you're going to want to try to keep separate from some other information that you're going to get today, because you're going to get something else that's going to end up being called, I believe, the orthocenter of a triangle. So the centroid is separate. Okay, centroid is where we have a line. It's where three medians cross. Okay, the centroid of a triangle is the point of concurrency of the three medians of a triangle. This point is also called the center of gravity. So if you see a question that says, where is the center of gravity in this triangle? This is what we're talking about. And the three medians of a triangle are always concurrent lines. They will cross at a singular point. Okay? And this is what that'll look like. Now, granted, this is just a real basic triangle. They can have different shapes, right? It could be obtuse, it could be right, it could be acute, right? Here's an example with an acute triangle. This is our theorem 32-1, the centroid theorem. And the centroid of a triangle is located 2/3 the distance from each vertex. So what we're saying is that from point B to point P is 2/3 the total distance of the line. Okay, so if I know what the distance of BY is, all right, I would multiply that times 2/3 to get BP. You follow me? And if they ask me, well, what is PY then? Well, if we're talking about thirds and 2/3 is BP, then how many thirds is PY? 1/3, right? So if I knew the total distance, I could figure that out, right? So they're going to ask us to solve some questions about distances in terms of these median segments. So in a triangle ABC, CP is 2/3 of the whole line of the red line CZ, BP is 2/3 of the blue line BY, and AP is 2/3 of the green line AX. In the same sense, PY is 1/3, PZ is 1/3, and XP is 1/3. Okay, so the medians are the entire line. The entire blue line is one median. The entire red line is one median. The entire green line is one median. And point P is the centroid, or the center of gravity. Okay, so do we know what all our terms are and what they mean? Okay, now if we ever had to draw something, the easy part is picking, a vertex. The next thing I would have to do if I was going to draw a centroid is find the midpoint of the opposite side before I drew my line across to it. Does that make sense? Because you'll get some questions where you actually need to do that. Okay? Well, they're going to say, find the coordinates of the centroid. All right, well, that's going to mean finding the midpoint. Do we know how to find the midpoint of a line segment? Yeah, we take the two coordinates. We get x1 plus x2 divided by 2. We get y1 plus y2 divided by 2, right? And we find the midpoint. Right? From there, I can draw my line from C to the midpoint of the coordinates where C was located. And I would do that 3 times and draw those lines. And after I've drawn all 3 lines, where those 3 lines intersect, right, that's my centroid. Okay? Or the center of gravity, depending upon how the question is worded. I don't know if I've made that clear. Hopefully I have. Okay? Because you're going to have to remember this on top of all the other information that you've already been given, okay, with everything else. And so something that seems simple, seeing it here, I've got the visual, he's explained it, and this is all I have to know in this moment, that's really easy. But piling it in on top of everything else can be hard, okay? Next thing, is what we call the altitudes of a triangle. In this case, where these three lines cross is called the orthocenter. And the rules are different because the rule is that we still take it from the vertex, but we're not looking for the midpoint. We're looking for where on the opposite side is my line going to be perpendicular. Okay? I want to draw a line from a vertex to the perpendicular line to the other side. Okay? And where those three lines cross is called the orthocenter. So the altitude of a triangle is a perpendicular segment from a vertex to the line containing the opposite side. The orthocenter is the point of concurrency of the three altitudes of a triangle. Okay? And because it works like that, we wind up with different scenarios for different types of triangles. For instance, on a right triangle, the orthocenter is going to be at the right angle because, all right, from this point here to be perpendicular to this line is going to be right here, right? That is the point where this vertex is perpendicular to that line. Do you follow me? And the same thing happens from this vertex to this line, that it's there, okay? And from this point, right, if we go from this point to this side, right, I have that line, and it's perpendicular there, but all three lines meet there. So on a right triangle, the orthocenter should always be at the right angle vertex. Okay? Now with an obtuse triangle, what happens is that the point of concurrency, or the orthocenter, occurs outside the triangle. So in an acute triangle, the orthocenter will be inside of it, right? In a right triangle, the orthocenter will be on it. In an obtuse triangle, the orthocenter will be outside of it, right? So if you see this, if I'm trying to draw a line from this point to the line that would be perpendicular to the opposite side. Well, the problem is that based upon how this line is slanted, right, I got to do things a little bit differently. And this is probably the most confusing and hard to get straightened out example of trying to draw an orthocenter when you have an obtuse triangle. Okay, because we end up with having to draw lines and triangles that exist outside of our original triangle. Okay, so you wouldn't offend me if you were confused by how on earth did you draw that obtuse triangle and how did you get that orthocenter. All right, hopefully we'll understand a little bit better as we get into some of these other triangles. All right, some of these other questions. Okay, that's it for that. So you're only really dealing with centroid, and you'll certainly deal with centroid more than you will orthocenter. So midpoint formula, and then being able to draw those lines back to each other. So let's pull up some questions, see how much of this we can get nailed down. Okay. All right. So this one starts off with medians. Medians means, it's going to get me to a centroid. So it says I've got triangle A, B, and C. BY. Okay, BY is 16.5. CO is 15. AX, okay, this line all the way across, BY and CZ are medians. We want to find just BO. Okay, so they give me some information in here that's not necessary. Right? That doesn't happen very often, and usually I tell you that, hey, if you got a question on the test, they start throwing out numbers, you need to look for how to use it because they're probably not giving you information that you don't need. In this case, they do give you a piece of information that you don't need. You don't need to know the length of CO. CO is not helpful in this case. Okay? But what do we know about BO? 2/3 of what? 2/3 of BY. And do we know what BY is? All right, so what kind of equation could I write to solve there? 2/3 of, yeah, so what math am I doing? 16.5 times 2/3. Okay? So you're just going to solve that. It's 11. Okay? Equals 11. Okay, do we understand that? That wasn't too terribly difficult, right? And if we wanted to find YO, right, we would take 16.5 times 1/3. So big deal there is making sure that you're answering the question that's asked, right, that you're identifying which information that you need. I've seen number 1 on a test. I've seen, I believe, this question number 2 on a test. In fact, number 2 showed up multiple times, and I end up DSAing kids all the time for this question because the answer is really not terribly hard to see, but in terms of showing your work, it's a little difficult. Okay? So the diagram shows a new kind of triangular bread. Where should the baker place her hand while spinning the dough so that the triangle is balanced? All right, so what we're looking for is the center of gravity. What's another word for center of gravity? Centroid, right? And centroid uses what types of lines? Is it using altitudes or medians? Medians. Medians are drawn from a vertex to where on the opposite side? The midpoint, right? So if I was going to draw a line from point A to somewhere on BC, right, how would I go about doing that?
Well, we asked you want me to give you the middle of the plot?
No, well, before we can find the center of gravity, we have to draw the 3 lines and see where they intersect. Okay, now granted, yeah, you could probably look at some of these and eliminate wrong answers, but you're not always, in the world that we live in, you're not always given multiple choice. Okay? All right, so the first thing we're going to do is we're going to write down our coordinates. So we got, well, let's do this in order. What are the coordinates for point A? -3, 0. What are the coordinates for point B? 1, 2. And what are the coordinates for C? 5, 1. Okay? So if I want to find the midpoint of BC in order to draw a line from A to there, I need to use the midpoint formula, right? So what am I adding? 5 plus 1. Okay, good. 5 plus 1 divided by 2, and? Okay, so 5 plus 1 is what? 6 divided by 2 is? All right, so we have coordinates at 3, and 1 plus 2 is? Okay, 3 divided by 2, all right, which would be 1 1/2, right? All right, so what we're going to do is we're going to go ahead and plot that point. We're going to go over 3, up about 1 1/2, which comes out to about there, and I'm going to draw a line. And with the construction, it's making it really tough because it's bouncing my board all over the place. All right, so that's one line, okay? And that's the work that I'm going to show if I see this question on a test, okay? The next thing, let's go from point C. All right, what 2 coordinates do I want to use? Or where am I looking to draw this across to? Between A and B, right? Okay, so somebody else besides Chandler, Jose, can you tell me what I'm going to write for my midpoint formula?
5 plus...
We're trying to find somewhere between A and B.
So, 8 plus 1.
Okay? Okay?
0 plus 2.
Okay. What's -3 plus 1? What's -2 divided by 2? Okay. And 0 plus 2? And 2 divided by 2? Okay, so that's the coordinates of what I'm going to draw over here. So -1, 1. So I just draw a line straight across to here. Okay? Now, I get that you probably already know the answer to this, you know, that you would maybe stop there. But in other questions, they're not going to be quite this direct. Okay, so See, Jordan, we want to draw a line from B, okay, to a point on AC, correct? Okay, so we're going to use A and C. Give me my midpoint formula for AC.
Negative 3 plus 5.
Okay, okay,
0 plus 4.
okay. What's negative 3 plus 5? 2 divided by 2 is 1, right? 0 plus 1, 1 divided by 2, 0.5, okay. All right, so down here we're at 1 and 0.5, right? We're coming across here. So my center of gravity is at that coordinate right there. What are the coordinates at that black dot? 1, 1. So a good way to get your answer right and not get credit for it is to see this question. Oh, obviously it looks it looks like 1, 1, so we're going to say 1, 1 and move on to the next question. And you won't get credit for it, okay? I want to see the midpoint formula done 3 times, okay? All right. Let's see, let's come down here to number 3. Where is the orthocenter of a right triangle located? Does anybody remember? The vertex of the what? There's 3 vertexes on a right triangle.
The one with the little square on it.
Right, so the vertex of the right angle. I wish that this was more clear. I know that you're going with this. It's not the exterior of the triangle. It's not in the interior of the triangle. And it's not even not enough information. We know where it's going to be. Let's see if I've got. So, but it really should be at the right angle vertex. On the median of a triangle, the distance from the vertex to the centroid is 8.2. What is the length of the median? All right, so in this case, we know the 2/3 part of it. Well, we just need the rest. So the equation that we would write is that 2/3 of something is 8.2. 8.2 is the 2/3, right? Okay, so what do I do to solve for what it's 2/3 of? By? Can I divide by a fraction? Can I divide something by a fraction? Multiply by the reciprocal, right? So multiply by 3/2 on both sides. That's going to cause these to cancel out. So what does x equal? What is 8.2 times 3/2? Jose? 12.3 is correct. Okay, so we understand how to set something like that up where we're looking for a different part than what we were looking for last time. Okay. All right, in triangle RST, SC is 6. So all the way from here to here is 6. We want to find just this distance. All right, what do I want to do there, Chandler? What is CX to the whole line? 1/3. So what do we want to do with 6? Okay, what are we looking for? What are we trying to solve for? Are we trying to solve for SX or CX? All right, so why are we using 2/3 when you just told me that CX is 1/3? Okay, 6 times 1/3. Okay, which is the same as doing what? Do you know? Jordan, what's 6? 6 times 1/3 is the same as what? The whole side. You're right. You're maybe just not what I'm looking for. It's the same as 6 divided by 3, correct? We can do that in our heads, can't we? 6 divided by 3 is 6 divided by 3,
Oh,
2. Yes. All right, so CX should equal 2. You're okay. It's first day back, long weekend. All right, we get that? Okay. You guys, if you want, the answer key is still there. If you have your homework done, you want to go ahead and get that created and turn it in to me, okay? All right, let's see. This next one, they don't show you the triangle. That's usually a good indicator that I probably need to draw something. In triangle XYZ, XA is a median, and M is the centroid of the triangle. What is the length in centimeters of XM if XA measures 161.4 centimeters? Okay, so this kind of comes back to you. You can go back and you can even put it in, even into this picture. It's the same concept. They're just moving the letters, or using different letters. If M is where X is, right, and so XM would be, would be this length here, would be the same as RX. Okay. If XA is a median, M is the centroid. What is the length in centimeters of XM if XA, which is the whole line, is 161.4 centimeters? The only thing I don't like about this is that you're not told which part of it is going to be 2/3 or 1/3. I think the assumption is that the XM is the 2/3 length. So if you have 161.4 centimeters, you're going to multiply that by 2/3, right? What's 161.4 times 2/3? And 107.6 is your answer. Does anybody want me to draw a picture to help you see that a little bit better? No? If you do, let me know. Okay, finally, I think question number 7 is our last question. Find the centroid of triangle EFG with vertices -4, 1, 2, 3, -4, -2. So again, what we would do with this is you would put this on a coordinate plane. We would plot those 3 points. We'd find the midpoint 3 times. We would draw those lines across and find where they cross at. Your answer for this is -2, 1. This would be a good one to work out in your own time, but I don't think we would get it done in 3 minutes. I want you guys to have time to work, and I can answer any questions that anybody has. Okay? So we'll stop it there.